Okay, so now let's discuss datum target points. They identify the location where a tooling or processing equipment must make contact with the part. Um, to simulate a datum target point for a part, you could use a spherical ended tooling post that will contact the part as a simulator. Each point must have a defined location or dimension. That's what we're seeing here. So we're seeing this is how it would be depicted on a model, and here's how it is depicted on a orthographic view. Um, so we have targets listed here: A1, A2, and A3. There's three of them because 3 points define a plane, and that's our primary datum. Okay, and then we have our target points for B. There's only two because that is a secondary datum. You only need 2 points to line up on a secondary datum, and a tertiary datum is three. Um, Here you only need 1 point for a tertiary datum. Okay, so these drawing dimensions locate the position of all of the datum targets, both in three dimensions essentially. So location dimensions may be basic or have a tolerance, and then 3 points define a primary plane, primary datum, and then 2 points would define a secondary datum, and then 1 point defines a tertiary. So I've got three A's, I've got two B points, and I only got one C point. So that's how we use datum target points. Um, so how to apply these to a drawing? Okay, so in which case we have our circle here, we have a horizontal line, we have our datum identification A1 in here, and we have a solid line and then no arrowhead on our leader pointing to our point, which is just like an X. Now if we saw that in a side view, here's how it would look. It would look like an X here on the surface of the part. Now look at this case here. So in which case we're making this leader line dashed. So that what that really signifies is that that datum is on the far side of the part. That datum point is on the far side of the part. So a datum target symbol on the far side, hidden, may be identified in an orthographic view by using a dashed leader, but it is clear when the views are selected to allow solid leader lines. It is not necessary to create an individual view just to avoid the dashed lines. Okay, so if you really get in a pinch on your drawing, you can use a dashed line and identify this on the wrong side of your part. Here, how to define reference frames using datum target points. Okay, so in which case we talked about this. We have these point contacts. 3 points define the primary datum A. 2 points define the secondary datum B, and then 1 point defines this tertiary datum C. 3 points define a plane, so we have these 3 points here on our simulator that pick up the part on those 3 points. And then we have our 2 points for datum B, and we have our third point here for datum C. So target points may be used to establish all of the datums for the part, and target points are commonly simulated by spherical ended tooling posts. Okay, so let's talk about datum target lines. Okay, this one, a datum target line, and identifies the location where datum target simulators are positioned. The simulator must make line contact with the part. Shown on the drawing is a phantom line, so we're going to show a phantom line on the drawing here. This is actually for a model, but a phantom line on the drawing here, and then our identifier for a line, target line. The side of a dowel can be used to simulate the datum target line. Okay, so that's one way to do it. And the end view of the datum target line appears as a datum target point. So if I was looking at this in an orthographic view, I would have an X there at that point. Okay, so what I want to do with the next slide is I want to compare this slide here, which is the one we just did. We just talked about it, where datum C here was a point. Okay, now what happens when we make datum C a line, a target line? How does this vary? Let's take a peek at that. Okay, so what we have here is we have a datum target line here for datum C. At the end view, at the front view of this orthographic view, what we have here is we have this datum target identification. It looks like a point on the surface, so a line at the end view kind of looks like a point. And then we've replaced our pin, which contacts it in a circular point, with the pin coming from the other direction, which contacts it in a line. So let's take a look at these two. There's the one with the point contact. There's the one with the line contact. Okay, and it's a different way of simulating the datum with a point and line. And this is a pretty good picture to illustrate, how this works with a point datum target and with a line datum target. Okay, so lastly, we'll talk about these datum target areas. They indicate locations where tooling surfaces that simulate the target must be positioned to make contact with the workpiece. Again, it's very similar to the points and the lines, but we're contacting the part over an area. And to do this on a drawing, we need to locate the area, we need to define the size of the area, and we need to label the datum target symbols. So the locations are going to be relative to other targets in the same reference frame, and standard tooling components may affect the decision for these sizes and shapes. So let's take a peek at one of those. Okay, so what we have here is a part, and again we have datum A, A1, A2, and A3. We have an area here that's a 375 thousandths diameter area about that center hole. We have those areas located with basic dimensions, and over here we have this entire surface of the area. Okay, and one of the points I want to make here is phantom lines are drawn around the perimeter of the target area. That's what you're seeing here, and that's what you're seeing there, except when the whole area is the target. Okay, in this case, this whole area is the target. So the intention there is that your datum simulator is going to pick up this entire area. Okay, whereas on these two over here, your datum simulators are just going to pick up a 0.375 diameter. So you're going to have like a flat dowel rod that contacts the part, and that dowel rod is going to be 375 in diameter. So that's how you place a datum target area. Okay, so simulation effects, datum features, target areas, target lines, and target points all have different simulation methods, and I've tried to explain that as these in the examples I'm using. So different effects on simulated datums relative to the datum features, and there's little difference if datum feature surface variation is small. And then the physical simulator must be sized to contact all of the surface to establish that datum plane. So let's take a look at a slide like this. Okay, so in which case, this kind of talks about what we talked about before. In this case, this is this point, and this is a line contact. In case we used a spherical ended tooling point to simulate this one. In this one, we used a knife edge part to simulate that line datum. Okay, so in this particular case, we have a target area and we have the size simulated. So our simulator is just going to be a plane, essentially, that just picks up, in this case, a block that picks up the size of that area. Now, in this particular case, we named the whole surface over here as datum C, in which case we need a datum feature simulator to pick up that entire surface. So that's what that means. Surfaces as datum features. Okay, let me pick this one up in the next movie.